So what's up guys, I'm back today with another video, and this is going to be an ongoing series teaching you about my favorite operating system, the Linux operating system. It's what I use on a daily basis, it's what I plan to use throughout my career, and I just wanted to show you how great it can be and essentially teach you, because this is now what runs the world. It is what will continue to run the world for the foreseeable future, and you need to know about it. So let's first understand, what is Linux? Why does it matter so much? Why do we even care about it? So to understand what Linux is, we first need to understand what an operating system is. An operating system consists of a kernel and an assortment of programs which abstract hardware to the point where programmers can easily write applications for the users to use them. When you use your computer, you don't really think about how much RAM to allocate for Firefox, where to physically put the file on your hard drive. You kind of just use your OS and it handles all that for you. More specifically, that is handled by something called the kernel, which handles all low-level interactions with hardware and gives you an interface between the hardware and the applications which the programmers write, so that you don't have to worry about any of that. So the collection of all those programs that you use, drivers, the kernel, everything together, everything you see, that whole collection of things is what an operating system is. And if you look at here at this diagram, you will see that we have the Linux kernel here in this space. We have what we call user space, which has our applications, our window manager, which is how the windows and that we open and applications, right? How they're structured on the screen, you know, how they're placed on the screen, how we drag them, and all these kinds of behaviors between the different windows. Are they going to overlap over each other? Are they going to, I don't know, push, when you push a window, drag it over, is it going to bump some other window out of view, or whatever it is? The window manager handles all those kinds of interactions. Libraries which programmers might use to create more applications. And at the bottom level, of course, you see your hardware. So something I forgot while I was recording this was to mention that Windows does not have this clear separation of kernel and user space the way that Linux does. It's a little bit more ambiguous as to where kernel space and user space ends, and that's one of the differences which we have between Linux and Windows. One of the many. Now, when we're talking about Linux, we're really just talking about this component right here, the Linux kernel, and we see that we have this user space up here and this Linux kernel together, and we see that it says GNU/Linux, and we'll talk about what that actually means in a second. But the kernel component is really what we mean when we say Linux. Now in modern terminologies, we just say Linux and we automatically assume all of this stuff together as the entire operating system. Really, it's this kernel which was built by Linus Torvalds, who at the time was a university student, and essentially started this as a hobby project. He just wanted to create something that was similar to something called the Minix operating system, which just was a clone of the Unix operating system, and it just blew up. He didn't really mean for it to blow up and be this big of a system, but now we have it, and it's all over the world, running all kinds of servers. So you can see here, this is a letter, this is Linus Torvalds himself, and this is a letter that he wrote originally back when he was developing this operating system. He says, "I'm doing a free operating system, just a hobby, won't be big, and professional like GNU," which was something else which was being developed, and we'll talk about that. For 386 AT clones, that was a type of computer at the time. This has been brewing since April, and it's starting to get ready. I'd like any feedback on things people like, dislike in Minix, as my OS resembles it somewhat, same physical layout of the file system due to practical reasons, among other things. And then he talked about how he's currently ported Bash and GCC, which are some big tools within the Linux operating system. And really, most operating systems, you need these kinds of tools, which Bash is a shell, so you can run commands. GCC is a compiler, so you can compile code and create applications. And essentially, he speaks here, this is the beginning really of what Linux became today. From this email is where we pretty much can point back to as like the beginnings of this operating system. The reason why we say that the kernel alone isn't just an operating system is if I just hand you the kernel, you can't really do anything with it. I mean, sure, it can handle memory, it can handle file management and things like that. However, how do you interact with it? You can't just send commands to it. You can't just You can't just randomly click things. You need some form of other application built outside of it to interact with it, which is why we have this user space out here. And to interact with it, we use these system calls, which are programmatically accessed. It doesn't matter. Within Linux, a lot of times that is through the C programming language, but it doesn't necessarily have to be that. That's just what was there at the time, and that's what was used. Since Linux was just a kernel component and you didn't have the rest of it, in order to make it useful, we had to add in this other part called GNU, which you saw in this letter, he was talking about GNU as if it was its own operating system. And it is/was. However, it was not ever really finished. GNU really lacked a solid kernel, and you can see here the founder of GNU, Richard Stallman, who was another prominent figure within the free software movement, which is a movement which we'll talk about in a second. But he had all these tools, as you can see here in this image on the left, and this is the logo of the GNU operating system. GNU Her was what it was called, or is called, and he had no really solid kernel which he could use. So Linus provided the kernel, and he provided all the rest of the tools to complete an operating system. So some of those tools, of course, are like the glibc, which is a standard programming library so that you can actually write C code and create applications for your OS. The bash shell was something else was contributed, which you need to kind of send commands to the OS. And other things were contributed as well, such as just general tools for manipulating files. These are more Unix-y types tools, which Unix was the predecessor, which Linux and Minix were based off of. And again, we'll talk about what Unix is in a second as well. But all of these tools had to be built, and Richard Stallman provided them, and Linus Torvald used his kernel to bring value to those tools. The rest of the tools came around just from random developers around the world. It was kind of really a collaborative effort of open source software, people essentially volunteering their time writing this software and letting other people contribute to it, letting other people download it, manipulate it, until once you put all these tools together, you have a complete operating system, or what we call a distribution, a Linux distro. If you ever heard that before, it's this collection. All these tools, not just the GNU tools, not just the Linux tools, but your window manager, your desktop environment, which is how it looks, your file explorer, your video player. All these things are part of what make a Linux distribution. And when we look at all these tools, there's something very important that we do have to discuss, and that is they try to comply to what we call the POSIX standard. The POSIX standard is a set of standards which essentially was defined at some point, and they are really what outline what makes a Unix system. So the closer you comply with the POSIX standard, the closer you are to a true Unix system. It creates a more uniform and cohesive environment for users, administrators, programmers. To add on to this point, POSIX really defines the interface through which you interact with the operating system so that it's uniform throughout various Unix variants. And Linux itself complies in many ways, and it also does not comply in other ways. Usually, operating systems which are fully compliant are what we would consider Unix certified. And one of those examples, surprisingly, is actually macOS. macOS is a certified Unix operating system. So you can see here that GNU is not Unix, is what GNU stands for. So it's a recursive name. The G is GNU. And it kind of just repeats GNU is not Unix, GNU is not Unix, GNU is not Unix, etc. So the reason GNU is not Unix, the reason Linux is not Unix, etc., is because Unix is the original operating system from which Linux, BSD, macOS, all of these operating systems come from. It was originally an operating system built by Ken Thompson, Dennis Ritchie, and their whole team at Bell Labs in the 1970s. which they originally licensed out to AT&T. It was a very big deal back in the day. It still is. These are very famous computer scientists, very well known for a lot of their contributions. Ken Thompson and Dennis Ritchie, for example, they created the C programming language, which is what pretty much most of our languages these days are based off of. So Unix was a huge success. It kind of revolved around this idea of the C programming language, ease of use, ease of programming. This kind of it was perfect for its time. And it was quickly successful, and it was being implemented all over mainframes, especially because it was great at something which is called time sharing, which allowed multiple users to be on a single system at the same time, and it was overall success. However, it's something that was mostly reserved for higher education, bigger companies, large enterprises. You couldn't really just have a Unix OS in your house. It really wasn't feasible. So that's where Minix came along, which was a clone of Unix created by Andrew Tannenbaum. And it's a clone in certain ways, but at the same time, it kind of takes its own liberties and improvements based on Tannenbaum's idea of what an operating system should be. And that Minix operating system is what inspired Linus back here to build his operating system, as we saw, which is Linux. And due to the licensing to AT&T and other factors, Unix was very proprietary, hence why it was very much reserved for those bigger systems and those bigger entities. Minix, which was an educational project by Tannenbaum, and Linux, which was that hobby project, were meant to be free and open source. And when we speak about these operating systems that are similar to Unix, but really aren't Unix, we call them Unix-like. There's a lot of tools which are shared, so tools like ls, awk, sed, all these tools were part of Unix. However, with GNU, for example, they created their own version of these tools, which could be used in these Unix-like operating systems that aren't necessarily Unix, but they behave and interact in a similar way. When I say free, I don't mean free as in beer. We mean free as in software. And what does software freedom mean? And this is free software, something that comes from the Free Software Foundation, which stems from Richard Stallman over at GNU. And it's something which essentially means that software respects the user's freedom. This is from GNU himself. They say their freedom to run, copy, distribute, study, change, and improve software. You cannot impose on these rights, on these freedoms. And this allows for an incredible amount of collaboration, of improvements at an incredibly fast pace. Not just that, but it allows the user to truly be respected, and not just the user, but just contributors, the entire how do I say this? The entire community benefits by these freedoms. So now, of course, we understand where GNU is, Unix is, Linux is, Minix, and we can start looking at what other things came from this. So if you go down to this tree that I created, we have Unix here at the base, and of course we have Minix and Linux and GNU Herd, which you talked about earlier. They kind of, if you can combine together to create GNU/Linux, which is what we know today as the Linux operating system for the most part. But we also have these other branches. We have System V on this side, which stemmed off into IBM AIX, HP UX, Oracle Solaris. These are more enterprise things. You might see them in a mainframe or something like that, maybe at a bank. It's not something that you see all the time, depending on the industry you're in, but it's definitely there. It's definitely a big thing, so be aware of it. On the other side, we have BSD. And BSD is a different approach from System V. System V is more closely related to Unix. BSD kind of takes the Linux kind of approach, where there's some things that it pulls from Unix, however, and it is very close to Unix as well, but it takes a bit more freedoms to make improvements, and it's almost as if Linux was more Unix-like. We'll put it that way. And so BSD branched off as a NetBSD, which turned into OpenBSD. And these are two separate projects, but for the most part, that's I guess that you could look at it that way. FreeBSD, which is definitely still around, which there's a few different things that are based off of that. But one of the most known things that FreeBSD is used as a base of is for macOS. There's a lot of code which you can see if we go here to my browser. Second, we go here to my browser and we go to the Apple website. They have something called the XNU kernel. And the XNU kernel, if we go here to macOS 11.4 and we go down into, let's say, look for XNU. Where's XNU? Right here. And we go down into BSD. And let's say we want to go into the network and look at how they implement ARP on the macOS operating system. And here we have the FreeBSD source code. And we'll open this up in a new tab, in a new window. And we'll scroll down. We'll see here that this is licensed from the University of California, which is where BSD comes from. BSD stands for Berkeley Software Distribution. So Berkeley meaning UC Berkeley. So that's why you have that. And if you look at the code, this is Apple's code on the left side, and this is the FreeBSD code on the right side. There's a lot of similarities. All of this is the same here. All of this is the same there. This is the same. This is the same. They're here for the most part. There's some additional things added in on the Apple side, but for the most part, it's all the same. There's big chunks that are shared between FreeBSD and Apple's XNU kernel. So there's a lot of sharing that happens. And this is not just between Apple and FreeBSD. There's a lot of other sharing between other distros and other kernels and software. But this is just an example of one of those things. And so if we come back here to our PowerPoint, we can see how this tree kind of makes sense, and based off of what we just saw there with the XNU kernel. So going back to our distributions, our Linux distributions, we have thousands. I mean truly thousands. You can see up here, this is starting from 1992 all the way to 2021. And I mean, if I zoomed out, you would not be able to fit this on a screen. You would not be able to fit this on a poster. There's a lot of distros. And they stemmed originally from SLS Linux, which was then turned into really Slackware Linux, which is what most people know, Debian, and Red Hat down here. And these are really the big first players in terms of distributions. Red Hat is very important in Linux's history, as it truly showed that Linux did have a place in the enterprise world, that Linux could be profitable, that the open source technology could be profitable, truly, and it's very crucial to Linux's history and in general the open source movement. So from these, there's different branches which have been created. So from Debian, you'll see Ubuntu. Ubuntu is very well known. It's probably even more well known than Debian, I think, at this point. From Ubuntu, you have other small operating systems which stem off of there, that you may or may not have heard of, right? Mate, Pop! OS, what else is on here that you might know? Ubuntu. Yeah, there's all kinds of operating systems. From Debian side, we have things like Kali, you may have heard of, Raspbian for Raspberry Pi. There's all kinds of operating systems which are based on these initial 3 operating systems. And why are there so many? Simply because people felt like making them. I mean, if you wanted to, you could make your own distro and nobody's stopping you. It's like I said, it's that compilation of all those tools, the kernel. As long as you got the kernel, you put together your tools, you've got yourself a distro. So you can really do whatever you want. And so that's where we are now. So now you might be asking yourself, why do we have so many distros? What's really the difference between all of them? And so there's certain things, like major differences, that we can really tell initially. So first of all, one of the biggest differences that you can tell right away is based on what distro it comes from. A lot of times it's easy to tell due to the package manager. So package manager is how we install software on Linux. In my case, I run Arch Linux. Arch Linux is on its own little branch somewhere down here, and here it is. It runs Pacman as its package manager. That's how I install software. So if I want to install Firefox, I can look for Firefox and install it. If you're on a Debian-based distro, such as Ubuntu, for example, or Debian itself, you would use the aptitude package manager, or apt. And other distros, let's say Red Hat uses Yum or DNF now, which is a newer version of Yum, things like that. There's also a different init systems, which is something which we'll cover later, but essentially it's how services and programs get started at boot time. Different desktop environments might come with different distros. So I have Arch Linux, I have Windows, I do not have a desktop. My window manager, i3WM, creates these tiles for me, which I can manipulate. I can stack them together and do things like this, which normally you wouldn't be able to do with all kinds of OSs, and I do this all using my keyboard. I don't really have a desktop environment. I don't really need one. I don't want one. But if I wanted to, I could have one. If I go over to my VMs here, you can see this is Ubuntu, and it uses the GNOME, GNOME 3 desktop environment. And here we do have a desktop. We have our icons just like on Windows. We can right click. We have our applications. It looks very different. If you go here to Kali Linux, at least the modern version of Kali Linux runs XFCE or whatever. You can pick the default one is XFCE now. XFCE 4 is very simplistic. You can see down here we have this bar, Apple style. We have our terminal, our file browser, our web browser, our applications up here in the top left corner. They all look different. If I go to, this is Kubuntu, Kubuntu, and it's based off the KDE desktop environment, and it looks a little bit more modern, a little bit more simplistic, very clean. Again, all these OSs are different, and different distros might have different desktop environments. Just because I have Arch Linux, for example, doesn't mean I can't install this beautiful KDE desktop. I can. And I can install XFCE as well, and I can switch between the two, and I can install a third one and switch between all three of those. However, usually there's the default which they come with out of the box, and that is a differentiating factor a lot of times with different OSs, or different distros, sorry. And yeah, there's also certain purpose built. So I showed Kali Linux is a security distro built specifically for penetration testers. Same thing with Parrot OS. There's other kinds of distributions which are specifically built for forensics, or specifically built for servers. There's all kinds of different types of distributions and different reasons why they exist. Linux is very complicated, and there's a lot of things which have happened throughout Linux's history, which in a very short amount of time, and it's really developed into a very mature solution which is used all around the world. And I'll help walk you through getting comfortable using this operating system, understanding how it works, and we'll talk about what distribution we'll pick and all those kinds of things in the next video. But just for now, if you want to understand more of the history of Linux, I recommend watching this Revolution OS. It should be easy to find online, all over the place, especially on YouTube. It's already uploaded on YouTube. But this will give you a general idea of what Linux has been through, how it came to be, and what the free software movement and open source movements are about, which are big parts of Linux and why people love it. But other than that, I think I've given you enough information for today. Thank you for watching.